alaikum everyone. We have decided to keep the medium of the presentation in English because we do have this language barrier among us when we go somewhere. We do have this language barrier, so this is the beginning of the teaching and learning that to start with the English language. So I request, there is no limitation, but I request all the engineers and all the professionals to interact in English language. First of all, I will introduce myself. I'm Ali Khanan in the group, quite active, and working in Ashghal as a senior design engineer in the drainage department. I might be very good in my field, but I had public fear. Speaking in public, I had a fear of very big phobia. So this is the third time I'm trying to speak in public, and I'm thankful to the PPIQ Masharan that they have given me this opportunity. Because the last time I failed terribly. And when I recall that experience, so that you can experience of that.
No, you are doing this very well.
The presentations are mostly revolving around civil technology of engineering. Most of them are civil engineers and foundation engineers. And this is the beginning of the very first of the series of presentations we have planned for our this Hujra. We are taking this Hujra into a new direction. It was a humble beginning maybe 3 years ago, and we have come a long way since that time. And we feel proud that we are at this stage sharing knowledge, giving expertise, and from all the senior members who are working in very, very reputed companies on reputed positions to give and share their knowledge with you. I will introduce the first presenter. Let me go back to the computer. There is a mistake being done. I haven't edited it, but sorry for this mistake. This is Gul Hamid Khalil.
The title is correct.
Title is correct over here, yes. He is working with Dorsch as a senior geotechnical specialist. Very diverse field and a very complicated field also. And he is a graduate member of Institute of Civil Engineering, ICE, another cap in the feather in the cap. And you can see his introduction. 2003, he's working in various places and multinational, international, Emirates, Qatar, Bahrain, Oman, Djibouti, United Kingdom, and he is here at the Dorsch working on Lucelle project. I would like to invite Mr. Gulhamid Khalil, and I request everybody to listen to him carefully and interact with him. There will be, let me tell you about the agenda of the presentation. There will be presentation. We will try to reduce it to 10 to 15 minutes, and there will be a question and answer sessions after each presentation, where we will be engaging with the audience, and we will encourage them to have questions prepared. Notepad and pencils are there. You note down whatever comes into your mind, and remember one thing, no question is a silly question. We need to overcome this fear that if I ask this question, people will laugh at me, or people will think that I don't know anything. But no question is a silly question. If you don't ask, you will never know. So with this, I will leave the stage to Mr. Gulhamid Khalil Sahab to come and present his presentations with your clapping. Please, Gulhamid Khalil Sahab.
Thank you very much, Ali Khanan, for a brief introduction. When we founded PPIQ, my first suggestion, or you can say a portfolio was actually to educate our young generation, not only young generation, but the working engineers as well, as Mr. Khalifa also mentioned. So that was actually our intention of creating PPIQ, but this is the first one and we are happy to have this. You've got my brief introduction, so I'll just start my presentation not to waste the time because we got a bar of time of 15 to 20 minutes. So today's subject is enabling works for infrastructure project. Well, all our engineers, so people know what is infrastructure, but people might not know about enabling works. So it's actually the preparations of site. So enabling works, we prepare the site for main works, main concrete works. It could be bridge, building, tower, tunnel, any structure. So it encompasses excavation, dewatering, shoring, monitoring. Monitoring is very important when you're working actually in an urban environment where you've got to build road and build tunnels and build structure, not to actually harm those structures. So as I mentioned, the outcome is the site is enabled to work and you can maneuver around, you've got logistics. This is a project plan, Qatar, Lusail. The project which I'm talking about is 7B, the central zone of CP7B. This is, we can see Lusail City in progress. Overview, Lusail City cover around 38 square kilometer, home to 200,000 residents, and eventually it will jump to 450. 170,000 employees, the visitors. I mean, it's built for basically for World Cup. So you can expect actually the closing and opening both ceremonies over there. Well, the opening is still in Lurk, whether it is in Khalifa or Lusail, but I think it is planned in Lusail City Stadium. These are satellite images. You can see what was the situation of Lusail City in 2006. And, well, I visited in 2006 as well. I've never planned actually to be part of this infrastructure. So you can see the timeline with the changes in construction. So that's the scope of work. I would not go much into detail, as I mentioned that it's an infrastructure project. So you've got roads, underground car park, bridges, tunnels. The division of infrastructure is very important. You have to divide it in zones so better to control it. That's very imperative for any infrastructure project. So that infrastructure project has been divided into 7 zones actually, out of which zone 1, 2, and 4 were in milestone 1. So that's a schematic layout where various shoring systems like D-wall, piles, injection, which is cancelled later on, but I mean we got soldier pile walls over there. So the construction sequence for any enabling works is first of all survey setting out, all civil engineers know that, and then dewatering, because until and unless the site is dry, you can't work over there. We got a lot of issues with dewatering, however, I mean, we still continued after 1.5 years. So excavation is then come, so during excavation, when you face actually any loose strata, loose rock, however, it was designed earlier that we will face this and where to do what. So we got slope construction and then remediation. Shoring, so in shoring there are actually various kind of shoring systems. In the next presentation you will get more overview from our friend Anis, but we constructed diaphragm wall, soldier pile wall, contiguous pile wall, and secant pile wall. So those are actually 4 major shoring systems which we did, and it was extensive. In fact, still it is ongoing. We got all the walls constructed, however the anchors are still ongoing. Monitoring of slopes, adjacent buildings, piles, and this shoring system is very important actually to to verify that there are no movements in the wall itself. So the first imperative thing in monitoring is actually you need to ensure that the existing building, like I mentioned here, the LCL building, that there was a building actually adjacent to our tunnel which is already built, but we have to monitor it to ensure the stability of that building. For that actually we make 2 sets of contiguous pile wall. Milestone, that was a challenge. So in construction project, what is the challenge? I think planner would say milestone, and then the civil engineer would say the construction. But anyway, the important thing is milestone. You have to achieve that milestone actually to reach to the target finishing date of the project. So that was the imperative milestone we have to achieve by doing the enabling works properly. So that, as I mentioned, setting survey out, so you need to do setting survey out, which is not an easy job because there are a lot of developer plots surrounding this project, because this is the last project of the Redissun city, however, the major as well. Dewatering. So, as I mentioned, why we do dewatering? To make the site dry. However, dewatering in Qatar is not an easy job to do. You have to do a proper dewatering design to make the water down below the formation level. And the important aspect is actually the water level need to be always 1 meter below the formation level. Well, I told QCS to revise it because previously it was only 30 centimeter. So when I arrived here, I just told them it needs to be 1 meter. So we imposed this, and it was a QCS then later on that water need to be 1 meter below the formation level. So we installed 201 deep wells. Again, you got breakdown of the wells, so you need to have a redundancy system in the dewatering system, which is very important because in the failure stage, what you're going to do, you need to have a backup system always up and running to lower the water below the formation level. So we got actually tall plots in the surrounding as well, so you need to lower the water over there. So that was the purpose of building actually D-wall, to lower the water substantially. Dewatering, as I mentioned, so we got incapacity dewatering wells. Piezometers is important to monitor the water, because you can't monitor the water when you are constructing, so you have to have piezometer actually to monitor the water. Then you got a sump pit actually to collect the water. The purpose of sump pit is actually because when you go deeper down in the strata where you got the fractures, cavities, the water inflow varies. So it's unconfined aquifer. However, the water, when it gets down due to the pumping, you still have a water because of the fractures, and that water pressure is enormous sometimes. So you need to have a trench with a sump pit to lower it. And associated with electrical installation, as I mentioned, the redundancy in electrical installation is very much. There might be a few electrical engineers around who know the electrical systems. However, it is very important to have actually 50% redundancy in the electrical system as well. You need to have a backup generator always at site. Excavation, as you can see, the excavation. So you need to excavate with the right sequence. So the excavation was designed actually to have a safe slope. We got 2 kinds of slope, 1 to 7, 1 to 10. So those were the safe slopes. However, we got certain strata which are soft strata. We can't make it stable without remediation. So you need to remediate it. So the excavation, you can see the planned excavation is 6 million cubic meter. It's substantial. So you need to plan it properly. We reached until now 5.3 million so far. Slope construction, as I mentioned, so you need to have a remediation plan, as I mentioned. So we design actually remediation in a three system: drop chain link, fixed chain link, and shotcrete. I don't want to go into detail into these because it will take ages to explain. However, the drop chain link is for the limestone where you got a crumbly limestone where you got actually hazard of rock fall. The fixed chain link is where you have actually substantial rock fall, so you have to fix it. And the shotcrete, again, as I mentioned, if the strata is soft loose, then you have to have a rock wall shotcrete system which is again alternative actually to piles as well. So if you want to evade piling, you can do shotcrete. Again, it depends on case to case. Here we have substantially changed from piling to shotcrete because of achieving the milestone. You can see the drop channeling, how it is fixed. Rock bolts. So you drill a rock bolt in the cut slope wall, and then over the rock bolt you do a shotcrete with a steel mesh. Okay. So, well, sorry, there is a question and answer both in this slide. So we did a shotcrete, however, there is a still collapse. So why? Why it collapsed? Because there is a water behind the wall. You still lower the water at the formation level, in this formation level, the water is still 1 meter below. However, the water pressure is still here. Why? That's a question for you. You can think over it.
Because it cracks?
Yeah, you can answer me later on. You need to think over it. It's not going to crack. Okay, so as I mentioned, there are huge cavities. So when we face cavities, we have to stop at this level, maximum 3 meter, which is a safe distance we design already, that you need to have a 3 meter for the cavity. You need to stop if you face any cavity, because this cavity formation you can't face during the design stage for borehole, because 100 mm borehole won't give you actually this extensive cavity. So when you face it, you need to remediate it. So this is after remediation photo. And that is actually, as I said, you evade piling and you do shotcrete. However, still you have to reach the milestone.
I think you answered your question.
No.
You already answered.
No, that's not the answer. You think of it. So as I mentioned, there are 4 sets of shoring system. Diaphragm wall, soldier, secant, contiguous pile wall. Again, as I mentioned, I don't want to go much into detail, but these are the shoring system. There are a lot of other shoring system which you can do injection wall and stuff. However, these are the major one which we install here. And again, it is based on the site condition and the water condition, because we are just adjacent to the lagoon. Lagoon is connected to the sea. Fortunately, it was not connected to the sea in the first year. However, now it is totally connected, so the water pressure is now withstanded by the diaphragm wall which is constructed now. Sorry. So you can see the slope construction. So you have to stop somewhere to start actually remediating. Sorry, this is about contiguous pile wall. Yeah. Anchoring. Mr. Anis will explain later on. I don't want to explain more. I'm his consultant, so. All right. So anchor stressing, very important. The anchor stressing is very important because you need to ensure that the wall is built to design and you have the right loadings to it. So you have to do anchor testing to verify those loads. In this case, we got 600 MPa, I think. Yeah. Monitoring, very important thing, as I mentioned, that we are adjacent to the sea, and there's a key wall, existing key wall, which you need to ensure that it serves its purpose. So we were making diaphragm wall adjacent to it, but we need to ensure that the existing key wall is stable. So we install actually this prism system to ensure the stability. So we were actually doing monitoring daily basis until the diaphragm wall built. Some of the picture for monitoring. This is for the building which is built already. So again, we put a prism actually to monitor. This is inclinometer. Inclinometer is an instrument actually which gives you the displacement during actually the construction and after the construction. And you need to ensure, even after the construction, you can reduce the frequency, however, still you have to monitor it. We got few issues, I don't want to disclose it here, but yeah, we got few issues in monitoring. So this is a load cell, this is a third set of monitoring. And these are, as I mentioned, there are prism here and here. to ensure the stability of the wall. Geophysical survey is very important. As I mentioned, there are cavities, so you need to ensure the cavities below the formation level are encountered and you deal with it. Sorry, due to short time, I'm just running across. So geophysical survey, as I mentioned, we use actually multi-channel analysis of surface waves to ascertain cavities. When we encounter cavities, we deal with it with the grouting. This is basically a 2D model of a geophysical survey we carried out. BIM. This is not a new technology here now. I mean, they are working on it. I would leave it to Mr. Anwar actually to explain in detail. However, we use BIM technology across our infrastructure project, and it was very useful because you can see 3D, 4D, and 5D. And I can give you just one case study when we got actually anchor installed, and we had to do shotcrete works with the rock holes here. So we need to ensure that this clash doesn't happen. So you don't have to clash both the structures. Right, so we got a few issues during dewatering, so we made cross trench for dewatering system. That was a new we constructed. Trenches, as I mentioned, containing of fracture water. There were failures in anchors where retesting is done, and there were lack of pull-out tests, which I ensure they did a few more during the water pressures. Thank you very much. You can ask questions.
Thank you, Mr. Gulamin sir. It was a very vigorous presentation on a very fruitful one. Fahad Ismail from KEO. The purpose of this technical seminar can only be served if we interact, if we learn. The second most effective knowledge retention methodology is discussion and interaction. So we would encourage everyone to ask questions, whatever you have regarding the topic. Language barrier should not stop any of us asking questions. Urdu ke questions koi, Urdu ki koi, English ki koi. I'll start with Mr. Kifayat Shah sir. I think he have got some questions. Yeah.
Thank you very much. You did a great presentation. It reminded me of almost 22 years back when I started this infrastructure work. So, but no, since then I never worked on such projects, and it's fantastic. My question is for the dewatering. You mentioned dewatering. When you do dewatering in the construction, during construction phase?
No, before construction.
Before construction. Before construction and during construction?
Yeah.
Okay. So to maintain the dewatering, you give space for the construction.
Yes.
What you do in the operation. So do you do operation, in operation you do the dewatering, or you keep it as it is? So what you consider in the design, this dewatering pressure, the pressure of water for the structure, are you maintaining that after construction completed you stop it, or you continue to do operation?
That's a good question. Yes, the structural interactions comes in here when you build the structure. So you stop at certain level that can withstand the buoyancy effect, the pressure of water which is coming from. Okay. Now in this case, our structure is basically floating structure. So notwithstanding, you release the water, you stop the water, doesn't matter. In structures where there is actually a certain limitation, where the buoyancy effect need to be counterweighted when you are constructing, or as you said, for the buildings, when you stop at certain level the concrete, which can withstand that buoyancy pressure, you can stop the dewatering. In our situation, we can't stop it because you need to do backfilling behind the structure. So the truss and tunnel need to be built first, backfilling followed, and then you need to stop the dewatering stage-wise. When stage-wise, as I said, your question is answered here. You need to stop the dewatering stage-wise to counteract the buoyancy effect which is in the design. Is that sufficient? Thanks.
I believe Mr. Kaisar have got some question.
Thank you very much. Gurami sir, thank you very much for a wonderful presentation. It's good to learn about these things. The question was, is dewatering done on all projects, or is there a certain type of projects it's done on?
Yeah, it depends on the water level. So if your structure is below the water level, you need to dewater it. Yes, it is required in any project where the structure is below the water.
How do we know about the cavities and how these cavities will affect on rock walls?
Good question. Yes, very good. How we know about cavities, as you saw the presentation, the geophysical survey, the multi-channel seismic waves analysis, we did 2D for that. So we do actually a geophysical survey to ascertain those cavities. So those cavities are below the formation level, below the structure, right? So when you encounter it, I get the results and then I recommend what to do. Well, again, the third party is recommending, but again, I have to verify. The waves actually, when it travel in water or voids, it gets reduced. So you get low waves in cavity and water, high waves in strong rock and any strong strata, whatever it is. Is that enough? Or so we deal with grouting, so that, as I mentioned, so you do grouting for cavities.
Anyone else?
So this bearing capacity is not included in this bearing capacity.
Bearing capacity for?
Of the ground.
Yes.
Number two, continuous
No,
this piling wall, continuous piling wall.
Mhm.
After anchoring to do it more stronger. So it's not bear the pressure of water. Number two, how will keep it dry. Round the building, how we will keep it dry.
So your question number one is the bearing capacity of the ground.
Yes.
Yes, the bearing capacity is ascertained by the SPT, the standard penetration test. That is one test. However, we do certain other tests as well, like plate load test. So those are the two tests which ascertain actually the bearing capacity, the required bearing capacity of the ground. Your second question is about dewatering. So around the building, you mean?
Yes.
When you dewater, the well itself will not dewater only certain areas, but it's actually radially affected. So when you design the dewatering system, you need to ensure that each well is having a radial effect of the water lower than the structure. Is that enough?
No, permanently, how we will keep it dry? Permanently.
After construction?
After construction.
No.
Yeah, it will be continued this dewatering.
No. When we stop the construction, we stop the dewatering as well. The water will come back to its original level.
Can I answer him this question, if you allow me?
Yes, please.
Shortcut it. Whenever the water, the construction reached up to a certain height, this is, for example, key basement. Now the basement wall has been done, the retaining wall has been done. There are forces which has been waterproofing. There are forces which is balanced, and the designer has been calculated these forces. At that time, we tell the client or the consultant, tell the contractor, you can shut down the water.
And even the structure itself is
And what is the method of to avoid rusting of steel structure?
waterproof?
Waterproofing.
It's waterproof.
The whole structure is waterproof.
No, in the piling.
No, yes, I will answer the question. So when you, no, for piling there is no need of, because the pile concrete is sulfate resistant. The pile concrete is sulfate resistant. So the water will touch the concrete first, and the steel is inside the cake. But, no wait, now you are asking a good question in terms of piling. Piling actually is not a permanent system for the enabling works. It serves a temporary system. For the temporary tower, the pile below the tower as a tension or compression piles, those are permanent. That is different case. However, the shoring for temporary works, the pile serves as a temporary works. So the pile after 1 year, null and void.
Okay, anyhow, that answer Anis will give for the permanent purpose. So he will answer.
In his presentation, you
This
can
one is
get
just
the
a
plan.
temporary one for construction. I have one question. Only one last question.
last one is last.
Yeah, he's saying actually for me no problem. You can ask.
Actually, we will be having a question answer session at the end as well.
Okay,
So
second last
But
question.
anybody who is welcome actually.
Okay,
to
let's
press
say
the
second
button.
last. The last will be
Second last,
this one.
yeah, okay.
Second last. So normally when we are doing the raw foundation,
Yeah.
so our specs normally everywhere, even in UAE or in all countries, that the water level should be kept not less than 1.5 meter. It's normally saying 1 meter. I don't remember,
1 meter.
but 1 meter. 1 meter. Or
No, in QCS, it was 30 centimeter. When I arrived here to Qatar, I asked QCS to revise it.
Agree, but now, like for example, you are working in UAE, so all raw foundation, the water table should be kept not less than, let's say not less than 1 meter. So what is the reason of that? If we want to keep it now, you said that you ask them to revise it. So if we keep it as 50 centimeter and still we are monitoring and we keep the level constant at 50 centimeter or 60, why specific? They are saying not less than 1 meter. What is the reason for that? In during construction, later on, okay, you stop the operation and the water table will go high, everything is waterproof. But I'm talking about during construction. Why we keep it why 1 meter? What is the reason behind that?
Okay, so, well, I've recommended, so I'll explain, not in very detail because it will take ages to explain to you. I'll explain to you privately later. Strata. It's all about strata. The strata, which is soft, like mudstone, siltstone, claystone. Water retain in those strata for a long time. In Qatar, whenever we are doing actually a deep excavation with a raft in the deep structure, below this strata, we need the water always to be kept 1 meter below to make the area dry. You understand? Below the structure. So, when the water is interacting with claystone, siltstone, mudstone, it will exert a pressure, plus there is a pore pressure as well. So capillary pore pressure, this is affecting actually the structure during construction.
It means if we go less than 1 meter, then it will be more effective.
Yes.
So that is the same.
Yes, safe distance.
Wonderful.
Thank you very
okay,
much.
gentlemen. Okay, Mr. Gurman. Thank you so much. We will be having a question answer session at the end as well, so you can have your questions written down and ask at the end as well if anyone's remaining.
During dinner time.
Yeah, during dinner as well, because this is an interaction is the most important thing which we can achieve the noble cause of this seminar. I'll hand over the mic to Mr. Abdul Hamid sir to carry the program forward.
Thanks a lot, Abdul Hamid sir. So our next presenter is Mr. Anis Khan. Okay, so Mr. Anis Khan, he's working as a senior project manager with Bauer International. He's been working with Bauer for almost 16 years. Prior to Qatar, he worked in UAE and Pakistan as well with Bauer. And he has a master's and bachelor's from Ukraine. Mr. Anis Khan, please.
First of all, I would like to thank PPIQ, all admins, especially Ashish Sir, and all our colleagues who give me the opportunity to present my challenges in front of you people. PPIQ, I think the credit goes to Rashid Lala, which is not here, and Khalifa Khan, Iftikhar Bhai, and all those members who initiated this, generated this group. And we had a small get together in the beginning. Then we moved to Mazra for several gatherings. And I think this is the result of their gathering. Now we reached up to the technical aspects. So I would like to thank all PPIQ members for arranging this nice gathering to fulfill all the requirements of our fresh engineers and colleagues. Actually, Power Group, I will not go in detail on slide, word by word, it will be very long. I want to give you more information as much as possible. Our company is Power International, German company. It's located around 90 kilometers from Munich city, and it is 200 years old company. It came into being in 1790. We have around 8,000 staff and working almost every country in the world. Power Group has been divided into 3 segments: construction, equipment, and resources. Construction basically is a segment which I belong. Construction is taking the jobs, design and build, and executing the jobs. Second part of the group is equipment. We are manufacturing equipment for diaphragm walls or the drilling rigs, etc. Third segment is related to mostly environment, water, nature resources, and most of this group is working for water treatment, process technologies, remediation, and waste management. And also we have this rig. If you can see, this has been invented by Power, which can drill up to 1,000 meters. And Venezuela, at the moment, we have this project, and they are using for long deep drilling to explore the oil. Most of my things has been answered by my colleague, Mr. Gul Hamid. Actually, my specialty is deep foundation. We can't see anything. It is not visible like structure. My colleagues told me to make it challenges. Every segment is a challenge for us. So I took some challenges which happened with me in my practical experience in my recent projects in Qatar. I would like to brief you about my project, which is a diaphragm wall project. Most of the things was briefly explained by my colleague, Mr. Gul Hamid. It is a very big honor for us. There's such a big prestigious job, and our colleague Bakhtoon, he was leading from DOT's concerned side as a geotechnical specialist. We have several discussions before the meeting, after the meeting on the project, and it is great. It was a lovely time that we have spent with it. Diaphragm wall has a static and sealing function and can serve as a cut-off wall for dams or excavation rig, as a foundation, as the enclosure of structure. They are executed as a concrete or steel reinforcement concrete walls built from the ground level. This one, QDSBG, we have done a diaphragm wall in different sections. This is basically the plan for the diaphragm wall. We are drilling with the slurry and with the French cutter. And this is the diaphragm wall basically which has been constructed. So you can see diaphragm wall, anchors, first layer of anchors, and the capping beam. Good. During the construction, the challenges which I face
during the diaphragm wall is the massive cavities which we found in the strata. The cavities, the presence of massive cavities, there is the presence of massive cavities in the area which were detected during the ongoing excavation and dewatering works. The presence of such cavities has highly influenced the excavation of diaphragm wall in the following reason. Before, one guy asked what is cavities and what are the effects of cavities on the during the construction work. So these are the effects. The suspension of fluid polymer in the trench will collapse suddenly and unexpectedly into the cavity, thus leaving the trench unprotected and provoking a collapse of the trench, and in the worst case, the loss of a trench cutter in the collapsed trench. This is number one. Number two, the presence of cavities will further allow the concrete to expand outside the alignment of the trench and provoke a bulging of the concrete, which will jeopardize the concrete matrix integrity and impermeability, especially in the joints. Finally, the inevitable bulging of the concrete, which will have to remove during the excavation, works, costing considerable time and break. So in this photograph, you can see there we have cavities, and there was already a trench which has been made for dewatering. And we found that while we were working, we found the water is coming from the cavities and contaminating the dewatering water, which is against the environment. In this photograph, you can see we were working beyond this, around 40 meter, 30 meter, and during the drilling, this is our drilling fluid which is coming from the cavities, and it is collecting and accumulating and going to the sea. So we approached our designer, which is in Germany, and by the way, this design build project designed by Bauer from Germany, and we called our specialists what to be done to control the issue and to not delay the project, which is a fast tracking project, and to overcome the issue. This is how the trench, this is the diaphragm wall panel prior to the drilling and drilling fluid. This is the guide wall. Before starting the concrete trench, this is how it looked like. This curvature you can see is a diaphragm wall, the bund which was done by another contractor before us, and you can see the contaminated water. The contaminated water is due to the cavities, which is against the environment, and our work was stopped immediately. Good. Now I will brief you what was the engineering solution for that, because we cannot keep the water ingress to the sea, which will contaminate all the sea, and it will have environmental effect on the project. So the outcome of that challenge is to make Bauer approach to construct a grout curtain by injecting grout under pressure, and single pile wall construction, drilling and filling of 3 numbers of boreholes in primary panels and 1 secondary panels depth 20-30 meters. So the diaphragm wall basically is here, and we have around 4 to 5 meter gap between the wall and the sea, and then we propose a second pile wall to work as a cut-off wall and to make a special wall, and the water will not going through the sea directly. This is how we have come up with this issue. This second pile wall was not in the design. This is a variation and technical approaches. We got this as a variation, and we conducted this. It is not in design. By the way, this is a section which shows you, this is the complete diaphragm wall panel, and we have done in each panel 111 dewatering 111 wells, and with 20 to 30 meter deep before starting the cutting of each panel. So like this, we did a trial first. The first panel, we drill it and we monitor it, and there is no ingress of water to the sea, and successfully we made a report, presented to QDSBG, they give us a go ahead, and we continue with this, and we finish all the diaphragm wall. After the construction of diaphragm wall, we have to do ground anchors. The ground anchors are in 5 layers. The first layer this is the first layer, which you can see here. These are our rigs, which is doing anchors. By the way, this is the first project in Qatar where we have done a permanent anchors. Normally the anchors is only for 2 years, but here we have done anchors for 5 years, and these anchors are specially fabricated in Korea, and we brought it from there. So during the drilling of the first layer of anchors, where the water pressure, we were not expecting that it will go up that high. We found during the drilling anchors, in the first layer, we encountered huge pressure of water from the anchor. Imagine you are
Before going there, just one question. When you were doing the diaphragm wall, in this anchor the water was high pressure. At that time, the dewatering system was operational or not?
Dewatering system was operational.
Yes. But still.
But it has nothing to do to the water which is coming here, because we are making this wall in the sea basically. So the purpose of this wall is, this is a barrier for the wall and other forces.
No, but the water was coming from the enabling side towards the sea. No.
The water was coming from the seaside. Yes, the water is coming from the seaside. I will come back to your questions. So to overcome of this issue, what we have done, we changed the methodology of our anchors installation. We have done booster pumps to control the waters if in case more water is coming out. We have done grouting before installation. We have done drilling in stages. First, let's say if the drilling is 30 meter, we drill the first 10 meter and then stop it, grout it. And next day go for another 20 meter, grout it, stop it. Third day, go for the 30 meter, which is required depth, or 38 meter. Then we succeed like this. But we consume a huge cement over there. This is one of the challenges which I personally encountered during the anchors. I will show you some photographs for a diaphragm wall. Basically, this is also one of my projects. It is in Sana roundabout. This is the first time in Qatar, 6 basement parking. This is a 6 basement parking. Now this building, it has been reached up to, they finished from here, they reached up to here. Now it's almost 2 stories. So G plus going on. Here you can see anchors, studs, and these are the foundation piles which has been designed for building. And this is in Sana roundabout, 6 basement. Okay, I will show you some segments for piling work. This is one of our project which is called Mazon Tower. Basically in this plot there is 4 towers are coming, and we have to do the shoring system, dewatering system, and anchors for the 4 towers and foundation piles. I will not go in detail in this because it needs the whole one day there to explain. Okay, this is also some photograph from the same project. retaining wall, which is a second pile wall, and foundation piles. This is my lovely project. My first project is Doha Land. In 2009, when I came to Doha, and I was in Dubai till 2008 in Pakistan. Then I came here, I joined this project, Doha Land. Now you can see a huge building. I would like to share with you in Doha Land project, when I first entered in the client meeting, I found my friend Kifayat Shah. He was presenting the client side, and really I was very proud, and I'm still proud of him, that our Pashtoon brother is sitting in the client, which is a very prestigious client in Qatar Foundation in Qatar. Yes. Yes. Actually, I took this photograph from my previous, now not Doha Land. This is called Mashere Properties. Okay, also Mashere Properties. Few photographs here in Mashere Properties. We have done the huge enabling work. The first phase 1A, phase 1B, phase 1C. I was involved and busy in that project for 2 years continuously. We have done dewatering, second pile wall, and foundation piles over there, plus monitoring of the existing structure, which is very, very important. There are so many existing buildings and towers which we have to keep and monitor on daily basis. This is some of these are the foundation piles which I have done from the top. It was around 32 meters from the ground level. Apart from the shoring work, which I explained you, diaphragm wall, we are also doing a second pile wall and contiguous pile wall. Most of the stuff has been explained by my colleague Kul Hamid. I will show you some pictures now, the basic concept you already aware about it. Here I have done museum station. This is a museum station retaining wall, contiguous pile wall with ground anchors. Great. Piling, diaphragm walls, and our next activity which we are doing in almost every project is ground anchors. Ground anchors are maybe for new engineers it is very important to explain them. Ground anchors are used to secure pile wall, sheet piles, mixed in place wall or diaphragm wall, as well as the steep slopes. Permanent anchors and ground anchors usable for longer than 2 years, and thus part of the permanent structure. Permanent anchors are executed as strand anchors, single rod, corrugated tube anchors, single rod pressure. So we are doing ground anchors, and QTSBT, as I explained you, we have 5 layers around, we have to do around 3020 anchors. Well, grouting. Grouting is one of most important activity which we are doing also in worldwide, and especially in Qatar. We introduced a system first to the municipality to give us the approval to make the tunnel without any cutting disturbing the roads. So they give us. We have done our presentation to the client, which is Qatar municipality, and they give us one tunnel as a trial. If we succeed in that, they will give more tunnels. So our first tunnel was Corniche Road. It was a 57-meter long tunnel, and we have constructed this tunnel with the continuous flow of traffic without any stoppage. And by the way, Corniche Road, no one can stop the Corniche Road. So tunnel basically we are doing. Grouting is used. Specialist foundation engineer introduced grout material, water with hydraulic binders and possibly additives, and solution soft and hard gel. So Waqif to amateur, during the excavation soil stabilization shall be performed along the tunnel 56-meter long. The method, in tunnel, I will not go in this much in detail, but we have to do horizontal drilling with the special machine. It's called ABS machine, and this machine is drilling horizontally with the tolerance of 10 to 15 centimeter and in axis wide. This we have to make a shaft first, supported by struts. This is how our machine is drilling. Here you can see the road.
This is the tunnel between Suwaqif and Cornish.
This is the tunnel. No, this photograph basically is between Suwaqif and Ahmed. This is newly constructed. Yeah. This is our machine and working, drilling in the different levels. Here is the road basically.
This cutting head. Composed of what type of material?
This is a drilling bit with the special teeth. Is for the soil strata we are manufacturing in Germany, and it is working with a water pressure.
These teeth are diamond.
As I told you, it depends on the strata. If we have conchlorominate, if we have very hard, then we use diamond teeth. Normally, we are using a normal drilling bit. This is how it works. This is a different stages of execution. Here we found some challenges. We have encountered the high pressure of backflow, water found shaft. During the drilling, we found this water which is coming out from the borehole, and it was very huge water. We were unable to control it because we have, even though we have dewatering system which is running, and you have the traffic, and you know the importance of Suq Waqif. There is no chance to stop the people. So how we encountered this solution for that. Dewatering of the tunnel shaft consists of the drain pipe drills parallel to the whole length. So we have done dewatering wells, horizontal dewatering we have carried out to minimize the pressure of water. We have done throughout horizontal dewatering wells. Plus we install piezometers to check the level of water, and then in addition to this, we have put a booster system just in case if we found a huge income of water during the construction, which be controllable.
Parallel to the tunnel? Parallel to the
tunnel, yes. So when we know this, the water is here, we change the drilling material, which is the grout and water glasses and the drilling procedure, and we control the water. This is, I would like to show you, this is called PPIQ. It is Bauer manufacturer, we invented this. This is whenever we have a drilling procedure, drilling is going on, and suddenly the water comes, how we are controlling it, how we have to plug it. Because when you drill in the sea and the water is coming, you cannot keep it like this. It will fill the whole area. This is called PPIQ. It has a steel pipe, and in between the steel there is a special rubber, which there is a screw. We screw it, it inflates, and it covers the whole circumference of the hole. This is tunnel.
Oh, it will sustain pressure of water.
Yes, it will sustain pressure of water.
Oh.
Because there is a screw. You tight it. You tight it and it will expand more and more. This is like inflammation. There is a rubber tube which inflates while you are putting pressure on it. This is the tunnel after. When the tunnel is done, then this we have to core it and remove this portion. After that, we have to do the short gauge each segment. These are the pipes which I explained you. which we have done horizontally. So every 1 meter, we have to horizontally excavate with the JCB and put the reinforcement and shortgate. And this is after the shortgate, you will find this tunnel, and then we are going to hand over to our next contractor who will do the civil work, tiles and everything. This is, we are doing micropile also with the different length, and it was also conducted in QTSB. Thank you so much.
Thank you, Mr. Anisa, for your brimful of knowledge shared from your experience. Guys, any important question quickly, please? Yes.
Would you, especially the first project, where there was some contamination to the sea, do you think before you were asked to do that work, maybe by geotechnical studies or investigation, we could have avoided landing up in this scenario?
Well, good question. Basically, there is a lot of studies, and since then there is new technologies. During the soil investigation, there are some tests to be carried out during the testing and investigation, which we have some, give us some ideas that there are some cavities, but a lot of reports which is really contradicting what we are doing as a contractor actual on site. So there are changes in strata, which is supposed in the borehole log is showing totally different from what we are expecting in the ground. But cavities are there, and especially in Qatar, and there is solution, and there are different solutions. But one thing, one question was raised by one of my colleagues to Mr. Gulhamid, how we know that there is cavity. So Mr. Hamid, he gave explanation as an engineering voice, but I will brief you just for fresh engineers. The cavities encountered during the construction work, when your machine is drilling, how you know that there is cavities, there is a water losses. So when we are drilling, there is a sudden drop of water. The water which is accumulated there in the pond is suddenly drops. It means the strata, there is something wrong. Number one. Number two, we have a drilling machine in the area. The drilling has some torque. So suppose it's giving 5 kilonewton, and suddenly it goes, freely goes. So this is how we are encountering the cavities in the ground.
Okay, gentlemen, because of time constraint, I believe.
So the variation is to submit additional works. So was it approved?
Immediately.
So it was like they accepted because
we have done several workshops, and Gul was there, and we convinced them that this is the only solution at the moment, because we don't have time to redesign the whole structure, and we have done a presentation to the client, and they accepted it.
But usually the client state that it is your responsibility to confirm before construction that okay, like the borehole and everything you have to confirm.
Look, there are, it depends on the nature of the contract. Okay, if you want to play, we can play also, and but there are the clauses in our contract. If we found anything which is not related, which is contradicting to our reports which we submitted, definitely we can claim for this, and we got it.
Actually, some questions are very, very important. Even it's part of the presentation. My question was exactly in the support of this concept. We have one project with the same issue. It's in Daphna, and this was actually for Mr. Gulhamid, but I think you both are able to answer this. He used one word, which is geotechnical survey. Geophysical survey, actually. In our contract, normally it's written a geotechnical soil investigation is the responsibility in a design and build contract. We put the responsibility on a contract that he has to conduct a geotechnical soil investigation, and then he has to quote his price. In case there is any issue in the future in the physical state or subsurface status, there will be no claim. In one of my projects, when they start excavation, actually none of the tenderer, they are not doing any investigation in the pre-tender stage. They just quote the tender, and when they start the investigation and test, they found cavities, and huge cavities in Daphna area. Then they claim that this is something which is unpredictable, or it was unexpected, unforeseen. So we, as from MOI point of view, we raised this point and we convinced them. They were not able to get any variation. But I had the question for Mr. Gulami, that is there any difference between a geotechnical soil investigation or a geophysical survey? Because he says the geophysical is the only thing which we can encounter these cavities.
I'll reply. When you do geophysical survey, this is part of geotechnical investigation. So geotechnical investigation encompasses drilling, boring, geophysical survey, which is MASW or resistivity. The contract we are talking about, I'll reply to your question as well. Sorry, you asked Anis one question. Anis got the money, but our main contractor did not.
But that is also
Yes, because it's in the contract that, as Mr. Khalifa also explained, in the pre-tender stage, you have to ascertain that there are unforeseen conditions which you have to verify during the geophysical and geotechnical survey. And the thing is, it is already, the borehole drilling logs and the geophysical already showed you there are cavities.
So it's not unforeseen in this
case? It is not unforeseen, yes.
Thank you very much.
Okay, gentlemen, thank you, Mr. Mahmoud. We will have a question-answer session at the end. Because of the time constraint, we have to move forward. Apologies for that, but still we have question-answer sessions at the end. So I would request you to write down the questions and with the name of the presenter. So at the end we can have a discussion on that. To carry on the program further, I'll invite Mr. Ali Khana to take the program forward. Thank you.
So the format was like, we started with the foundation, which is the base of everything, and very beautiful and very enriching presentations by Mr. Anis Khan and Mr. Gulami. Thank you so much. The introduction was fantastic. A lot of the questions came from senior members, but I would like to encourage questions coming from the junior and the fresh graduates, so we can understand that they are getting the presentation very well, and they are.
They're not sleeping. That they are not sleeping.
Yeah, they're not sleeping. Exactly, that's what I mean. Now, I feel immense pleasure to introduce our next presenter, Mr. Anwar Shah. And his presentation is going to be very interesting, very related to the modern technologies in the construction field and infrastructure field. Mr. Anwar Shah is a department manager. Very proud, I need to clap for him. Mr. Department Manager, Water Process. And my village mate also from Swat, Tindodok. He is living in Qatar since 2012 with the worldly person. He is related with the worldly person, leading the infrastructure, and his experience can be seen here. Multinational companies and Ontario in Canada. He's and MSc from the University of Waterloo, BSc from the UT, and members of the professionals membership also. So without wasting any more time, I will ask Mr. Anwar Shah to come to the stage and do the presentation.
I'm really proud to be here for the reasons that I can see in front of me. This is a culture which we need to inculcate in our society. And you are the guys who are going to take this to take this further. The purpose of this presentation is not that what we are going to present. Yeah. The purpose is not that what we are going to present. The purpose is that what your involvement is going to be, and get up and ask the questions. The questions are the more important part of this presentation than the presentation themselves. And if you guys don't ask questions, and I will encourage my senior, they have brilliant questions, but please keep it after the presentations. They can ask this anytime. I will like the junior engineers to ask the question. And if they didn't ask the question, I will think that I didn't present well. So, okay. The presentation that I'm going to present is about BIM. BIM is not a software. It's a discipline, you can say, huh? It has been for a while in the West. In these countries, it is coming, and it is now being part of most of the proposals that are being coming out in the market. They are putting BIM as a requirement. So most of the design consultants, as I'm part of it, we now have developed these teams to work in BIM. BIM stands for Building Information Modeling. So it came from building, while this is infrastructure. Now, it is a building concept, but it is more on the infrastructure industry is now taking this also as a 3D modeling. Now, you are seeing this as a BIM and infrastructure asset management. I was trying, if the time was longer, I would have discussed the asset management side of the infrastructure and how BIM can help this. This is in fact a research topic, and any graduate engineer can take it further, that how we can get the benefit of the BIM while managing the assets. But I will be more talking about I will not go to the asset management because of the time limitation. But asset management itself, it is going to be very big coming into the Middle East, because the Middle East infrastructure has now been developed mostly, like in Dubai, everywhere you see. And the next step will be how to maintain and sustain this infrastructure. Because once in Qatar, you can see that most of the infrastructure is now being built, or almost in the completion stages. So how they are going to maintain this in the next 20, 50, 30, 50 years. And that is very important. Probably in the next series we can present this. So I'm just skipping this because all these are highways asset infrastructure and highway asset management. And if you guys are interested, you can ask me a question later. By the way, in Canada, I did all this infrastructure asset management quite in detail. Now, BIM, and how it is related to the infrastructure. So this is just a snapshot from Autodesk, and you can see that the building information, which is called building information modeling, but that is the building. But everything you see here, everything is in 3D. Everything you see here is in 3D. You can see the slopes. You can see the mast, the poles. You can see everything in 3D, and you can basically work this in BIM software. Now, the BIM has several softwares. Like every 3D software can be brought into any other coordinate software, and most commonly used software is Navisworks. We have done this for the Qatar Economic Zone 3 for 34.5 square kilometer, crash-free design of the entire infrastructure. You can run this model for clashes, for above surface and below surface. You can And it gives you the 3D view of the entire infrastructure, 34 point, I think I can do away. Guys, listen me clearly. You can listen. I think if you can listen, then I don't need this, huh? Because
you're facing difficulty.
Yeah. Wait, Ramzan, sir.
Like
How can I give it a model with this way, Master? The model with this way, and that's another
مرة مايكل جاكسون بتقول هو هذا
ده طول بتريدي كده ده infrastructure ده يوم مودري دي كده طول انا مزار خبر ذلك انا كسوق اسواق الناس اغهم بكار کولی شي او کسوق په قطر کې ناس په دغه یو ماډل باندې کار کولی شي دا دونه زبردست ټیکنالوژي ده او دا زمونږ د پښتنو لپاره یو ټول پښتانه یې که زمونږ لپاره ډېر زبردست یو موقع ده که چې مونږ دا په خپل ملک کې یوازې نه چې په پنجاب کې بلوچستان کې په سند کې دې کې مونږ مخکې لاړ شو ځکه چې the future is BIM. The future of all the design is BIM. All because recently there have been guys like Karim is there. I just saw him. He is working on BIM. He knows the 3D model. Although he is going with the Revit model. The Revit is an Autodesk, so I don't want to sell any vendor software. But that is most widely used one, as we see AutoCAD everywhere. So AutoCAD, Revit, Navisworks, all these are coming from Autodesk. Now going further, these are the above surface infrastructure that I was showing to you, all in 3D. This is all in 3D. So any design engineer who is working on this in a 3D can work on the entire project from any top part of the world. Depends on the availability of the servers and all those things, but he can work from any part of the world. The next one is, this is below surface. So you can see that all these lines, this is not a pole, this is actually a manhole. This is a manhole. These, what we are seeing here, although these are not a very clean model, because these are the masses of the building being shown above surface, but you cannot see the asphalt here. The asphalt has been taken away, and you can see all these manholes, these lines, all these are running. Now, these softwares have the capacity to run and give you a report that you have 8,000 clashes. And of course, this is not exaggeration, huh? There are. When you start this, you have those many clashes. So when it goes into construction and the contractors start working on it, 8,000 clashes, how to resolve this? And then you can see the number of RFIs that start flowing in, and the amount of time that is being spent on those RFIs. So you run the report in, I don't know how long does it take, Kareem? Just 5 minutes. 5 minutes, you run the report, and it gives you that the telecom is clashing with the LV. The LV is clashing with the potable water. Everything is. So you select, for example, potable water, and the potable water you select it and show me the clashes. Because above ground is very easy. Above ground you can see it, but below ground is the problem. And that will show that the potable is clashing with these utilities, and it will give you the exact location with X, Y, and Z. It will give you the exact location. You click on that, and you will reach there, and then the modelers go there and resolve those issues, the clashing issues. And you run those again and again. It's a laborious task, but at the end, during construction, it the purpose. It is the time saver. Unfortunately, the BIM is not fully understood. The effort needed by the BIM is not fully understood by the owners here. One of the owners here is PPIQ, because they think that we will just ask for BIM. Now the first BIM that I saw here, and I was not aware of BIM at all, like I didn't know what BIM stands for, okay, about 3 years ago. Then the scope is not clear, the effort, they don't appreciate the effort, they don't give the time, the schedules, all those things need to be part of the effort that it needs, and I can tell you how long the effort is. For example, now in the 2D world, what we do in the 2D world now? In the 2D world, for a profile, what we do is that we have one center line profile. And the best, what we do is that we create one more profile, and one more profile there to provide you the grading of the surface, like what the surface is, like it's going down, up, in which direction there is super elevation, all these things coming. But in BIM, you need a profile here. Profile, what I mean is the 3D. So the X, Y, Z of the entire line, like here it is going, X, Y, Z of the entire line. And what is this line, what is that line, what is that line, where is the curve coming? Now there is, of course, this shows like this is a straight slope, but usually it's not the case. It's a variety of the chances that most of the chances are this is not slope. There is a ditch here. So all those you need to provide the crosswalks. You need to provide all these 3Ds. Then that is a BIM, complete BIM. Otherwise, like working on this, like 1, 2, and 3. So the effort that I have counted myself is before, if there were 3 lines, now 24 lines are needed. So 8 times more the effort in the design is. 8 times more. That's why we do here, the government here in the middle starts to realize, but whenever we go back and we give this knowledge, and some of us, we never know, join the team in here or in our own country, can show this. That guys, you need to give the time, then you get the product. So this is the below infrastructure. This is again another 3D of the. This is exactly like a cross section taken, and you can see the different manhole, the different lines, and all those that are running. Now most of the
this grade is finished floor level.
There is no floor.
No. This grade utilities. What do you mean?
Sorry. No, I'm just kidding, so don't take it.
What means by grade? I don't know. I'm not something. Grade utilities.
Okay. Are you a junior engineer or you are a senior?
I am senior but electrical.
Okay, so you ask this question later, This is for juniors. Did I say that? You forgot, huh? Okay, how much time is it?
You can carry on.
5 minutes.
No, not few minutes. How much is that?
5 minutes.
Huh?
2 to 3 minutes.
Oh, okay. So I will only extend this one. The asset management, as I said, I want to explain the asset management concept as well. So when you have the BIM, you have every element of the entire infrastructure, and it can be connected to the buildings. The buildings and the infrastructure can be one model, entire one model. So you have every element of the design. Now I want to explain a little bit more concept from the BIM. There are levels of details. They call it LOD, level of details. Okay? So it is, they call it 1, 2, 3, 4, 4.5, 5 is rare. So So one is the concept. The concept, as I said before, one will be like to give you the three levels, the three lines. The other one is that LOD2 goes into a little bit more detail. That it will provide you with showing the pole. Not the details of the pole, what is this pole, but they show that there is a pole. I'm just saying this, just to you to understand. LOD3, and we can relate LOD2 to preliminary engineering. LOD3 is the one that you can see the details. The details are coming, you can say detailed design up to 90%. 3.5 is the detailed detail. And 3 and 4 LOD is short ones. So you have, and by the way, you can take 2D drawings anytime from this bin. So it's not only bin. All the things you can take anytime from the bin. So to explain the concept design, just consider that you have the entire, like in this room you have everything available to you. Now it has a design life, everything has a design life. How long it's going to stay. So let's the design life, most of the building is 50, right? I'm not a building engineer, but it's 50, 60 years. So, but it depends on the routine maintenance you need to do. So that maintenance you need to give a design life. So this is since construction, that's 30 years. This is, unfortunately, this is for roads. I'm a road engineer. This is for roads. The 100 is when it is completely new, fresh. And with time, it goes down, right? Unless you interfere with maintenance here. So here you can see, I don't think I will say you can see this, but you can, for the drop in the quality, is 40%, but the life is 75% here. This is a concept, I think it will take time. I shall skip this, huh?
I will have to. Can I ask one question? And if you explain, I think our audience will be much more satisfied.
Which one?
I want to raise one question.
Yes,
It's old engineer.
Sorry?
Old engineer, not yours.
Yes.
How the technology works, okay, you know better than us and it will take time. My question is that I have two cities. One is Doha. It is old. I have lot of utilities. I have lot of underground utilities like water lines, telephone lines, and no current as-built is available for the whole city. Yes. And I have a new city. I want to develop a new city in Gawada, which is just a free land. I want to apply BIM there. Of course, it is very useful because I will start from the scratch. So everything I will put in and BIM will work very quickly. And for the future people, it will be a very good asset. Am I correct? Yes. Okay. How I will apply BIM in Doha? I am a metro contractor. I want to run lines where I don't know as-built. Practically, I am in Qatar from 16 years, and a lot of things I encounter. Yes. Even those lines are totally not shown. In this scenario, when we are working in metro or in any other infrastructure project, how the BIM will be helpful?
And most importantly, his point is there is no as-built drawing. This is the case throughout Qatar.
Yes, this is most of the case everywhere in the world.
Yeah.
I will prefer if you finish your presentation and we'll answer the question after your presentation is over.
Yeah, my presentation is over.
Is over?
Yeah.
You are lucky.
No, this is a question, a very good question. Excellent question. Yes. I do not entertain seeing a question, but it's a very excellent question.
That's okay. Junior, that's your question. From there, take them out.
That is I'm junior. No, I will answer. Now. One thing when I start my presentation for my meetings anytime, One thing that really distracts me and I cannot present is when people start talking or playing with their mobiles. I cannot concentrate, this is my problem. Yes. Anytime people start talking, I stop. So, and any guy who has a mobile and he drinks, he will not be in the meeting next time. He has to put up his mobile.
Warning to all.
And nobody should walk out and the phone rings. Yes, nobody should walk out because you are here for the meeting, for the conference. You are not here to entertain me. You can go out later when it is done and disappear. Even if it is your boss. And I have shown this to my colleagues. Which is from the GM office. So the BIM is not answer for this. Now, the answer is the BIM being implied when the new developments are coming? That is the question. And the answer is, most of the cases, no. That is the answer. Is the BIM being implied in the proposals? Who is going to take care of the BIM? If I give the BIM for the education city to find shop now, okay? Who will take care of this? Is the client ready for it? No. Forget about the old ones. The new ones is not being implemented, not fully understood. They need someone, at least two guys, to know what this asset is and how to take care of these assets. These are huge assets. Where have these come from? This asset management. Asset management started back in the 70s. It's late 68, 69, 1969. When USA, after the war and infrastructure is being built, they realized how we can take care of this. Now, a 20-year life, we need to extend it to 50. How? And again, that was a Muslim who started this asset management. The models he started to develop from Egypt. Shaheen was his name. And he worked for the Corps of Engineers of the US Army. And so the assets that need to be taken care of, the existing. Is it or not there? There are other ways to do it. I can discuss further. There are other ways, like the geophysical. Geophysical, they can detect all of these because they are not that deep. Yeah, they are not that deep. They can all detect these. Okay. So this is the information for you guys. The idea of this is that you take the terminologies and go back and do some research on this. That these presentations are just like for you guys, the young engineers, to note the points, and you are available anytime. You go back and do a little bit of research, because your career is the most important thing for you and for us, because this is a that's why I am, I think, more excited than before. Is that you guys, when you reach some level, you will be taking this technology and you will be doing these things when we are here. So this is a start which I am really proud of. Now, I need some questions from you guys on this one. Yeah, okay. This big, I can hear. Everybody can hear. Yeah, no.
Yes, it's the first time I've heard about this thing.
Okay.
Is it implemented in Qatar and in any of the projects?
Yes, I am. The BIM is, as I said in the start, that the West have made it compulsory in majority of the cases, including infrastructure. As I said, that it has been implemented in our projects, like we have completed the Qatar Economic Zone, not the detailed design, but we only did the preliminary. We completed that, the 34.5 square kilometer, and with 0 flashes of the utilities. Above is simple, but below is a mess, and then anybody can see that, especially at the intersections, when all these things are coming and a number of lines are running. We also currently working on on the cutter rail stations, all the metro lines, those are all in beam and detail beam. A lot of detail. What has happened to the Qatar Economic Zone 3? They took the beam from us. There's no one who can play around with it. Okay? And now, what the contractors, what the tenders are coming out, they are putting on the contractor to do the as-built beam at the end. As-built at the end. So the coordination and all this design, when it is completed, then it will be done. Like it doesn't make sense. I'll give you one example that how beam can be effective. Qatar National Museum, the one under construction. It is the perfect example of beam that has been done. It was not us, it was somebody else, but I attended the presentation. There are many thousands and thousands of panels that you can see. But you know how many panels were designed? Only 28. Because of them. Only 28 panels were designed. So you can see that the amount of manufacturing cost that was saved. And then in construction, every panel was, a constructor knows where is this panel going to be in construction. But the spirit of beam needs to be understood, and that is lacking. But for you guys, it is a start. I'm looking at this like mostly because most of the engineers are here, and this is a start. And you guys need to go and start further research on it. You guys can download Revit 1 month free, and if you are still students, you can download it from your university. Talk to your professor; they can download it free. It's an expensive software, but if guys are interested, we can even help them with the software.
Revit and BIM, would you suggest this only for people into industry, or how about those who would like to go into academia or research? Like me, I'm a student from Qatar University.
Okay. For you, I just put this as a research problem. BIM, asset management versus in infrastructure. How we can make this, as I think I didn't emphasize too much on the slides, but there is a comprehensive asset management. So, but because the asset management is a different concept, which I do not want to explain and confuse it, but for industry, for the academia, this can become a research topic, that how we connect the assets and get the utilization of BIM concepts into asset management. Now the thing with asset management is that people need to know what is the depreciation model of every asset. That will be a challenge. So
one follow-up question.
Yes.
In the existing cities, do you think the challenge is having information for them? Because as I understand this, I think like if you want to implement this to an existing city or an old city, you need to have lots and lots of information about all the infrastructure below ground and above ground. Is that true?
If I have understood your question, you are saying that can we get the benefit of the BIM in the existing city?
Yeah, but if we cannot, is there reason information?
Yes, yeah. As you, most of our engineers who are related to construction, they know very well because they work in the industry here, the construction industry, that the existing information is not there. As-built information are not there. So you don't know where the LV line is here or there, or where it is running, and how deep it is, and where it is crossing, especially in the intersection. That's a big problem because a lot of lines are coming here and there. So that is, that being, as I said, cannot be utilized, but can be utilized when the information is available and can be detected by the surface, and geophysical is one of them that is can be got and then implemented into the can become part of the
Answers the
you will still face the problem because as-built here are also not very correct.
No, no, but if you take geophysical,
You need to detect by geophysical studies.
Yes,
So once you detect, you can always work on it. However, I would recommend actually this guy. What you can do is you need to study whatever is done so far, right? And then from there you can take, as Mr. Anwar suggested, you can have you take from there. Then, I mean, you can know, I mean, whatever you have data and what is required. So what is required, and this will help actually authorities as well.
Basically, the reason I'm asking this is what came to my mind was this. As soon as he showed me all those things, actually, my team, I'm with Dr. Saud Abdul Ghani, if any of you have heard his name, he's very much in touch
You're
with the
civil?
industry. Yeah, I'm in mechanical, basically.
mechanical.
But the thing is, when you showed me the pictures of Revit and SolidWorks, stuff like that, my team specializes in modeling, SolidWorks, Revit, and simulation from ANSYS. So what I was thinking is if we integrate virtual reality with this, so if it is effective or useful after construction, then I think you could, or any one of us could, bid for it in QNRF, because we have, I believe, enough information for construction of every below ground, at least enough for having a working BIM.
so virtual reality, you are referring to the 3D of the surfaces, right?
Yeah. Like you could walk in while having the, you feel like you're really into the inside the
Virtual
ground.
reality. Oh, virtual reality when you, yes, of course. You actually, we had we presented one to other rail. Virtual reality.
It does, sorry, it does work in Naviswork. When you actually open the Naviswork, the 3D, you can actually walk into it, you can run into it, it does work. in Naviswork.
Correct. Naviswork or even Revit or
I never work on Revit, but yeah, Naviswork works.
Because Naviswork is a coordination software. It brings, like for example, we have used Naviswork in the QVZ3 because we did 3D design in multiple software. We use 12D, we use Road MX, we use some other 3D softwares, and we use Revit. And then Revit, 12D, MX, Road, these were all brought together by Naviswork. But I believe, if I'm not wrong, is that Revit, you can do this. But so that presentation that we did to Qatar Rail was with virtual reality. The guys were very impressed, but they didn't give us the project. Our price was high. They give it
Yeah,
to
this is the actual one.
Okay, that's it.
I have a general question. Regarding the BIM users, like they are the design engineers, like kind of a software. So
Yes, yes, I want to cut it because it's short time. The best is that the engineer know BIM. BIM is like he know how to work on Revit.
Because now even I heard in the BIM also there is even PhD. Like there are a lot of research.
That's another. But nowadays what happens is that there are BIM modelers. They are not engineers, like they are as CAD technicians. You can say that they are CAD draftsmen. They are modelers. They don't know why I'm putting this line here. Okay. The engineers do the calculations and come up, okay, I need this much big file and I need the variables there, and they put them. The best is that the engineer need to know BIM. Why? Because it will increase the efficiency at least by twice. Because he can then guide properly the designer. Now he depends on the designer. He has done the calculations, but designer, I need the model. Okay. He has done the calculation, he has done everything, but he doesn't know how to do this. So he depends on that guy. So if the engineer knows how to do this, he can extremely increase the efficiency of the design. But it is not important, but it is not a requirement that the engineer need to know BIM. No, he can work without that, but the efficiency is not there. Okay, I have some questions for you guys. You have put them there? Okay. Who will ask? Please, what's your name? Not engineer. No, so you can still ask the question. Yeah.
And Rashad said, we will make this into the last. We are around here. We'll wind up and I think it's one of the best presentations we have. Thank you so much for your interaction. Thank you so much, Rashad said. Very well presented. The interaction with the young engineers and the way you motivated the young engineers to ask questions. We are having a bit to break the continuity of this presentations. I know it gets boring sometime. We will break for a few minutes, but I advise or I request the people not to leave the hall. We don't have much time, but I will make this session as a brief introduction of each. It's a break time for 10 minutes. You can have coffee. You can network with each other. And after that, we have 2 more presentations remaining, where will be Mr. Arshad Hussain and Mr. Kifayat Shah will do a presentation. So we'll break for 10 minutes, but how about each one introducing himself and his industry he's working for?
Can you start from there?
I will start from there and I will pass the mic there. Yeah, it's a quick, just name and your industry and your company, that's it. Yeah, 4 things. I will just name your profession and your industry and your company and your back in Pakistan where you belong from.
हाँ जी हमारा मोहम्मद रशीद खान है स्वाद सर जमा ताल्लुक है
खैर कलीवाला
आईटी सर आईटी बैकग्राउंड है मां और कतर इन्वेस्टमेंट अथॉरिटी के कार को लदना मुख्य कतर स्टील क्यों मां दाना मुख्य अली बिन अली क्यों मां कतर पैदाइश थे हम
अस्सलाम वालेकुम जमान लवीद और तालुक में सोहाबाई सर है और सिविल इंजीनियरिंग or working as a planning engineer, planning and project specialist and cost engineer, or started like I was in worked in Dubai for like 4 years.
Brief.
So Parsons Brinkerhoff, then shifted to WSP Parsons Brinkerhoff, now only WSP.
Just current job. Assalamu alaikum. Zamanum Khalid Khan de और तारुक नस्वात सर ग्रीन लाइन अंडरग्राउंड दोहा मेट्रो के बारकों में और एज एडमिनिस्ट्रेशन कोऑर्डिनेटर
मालूम का युलादी ताल्लुक में चार सदी सर है I'm working as a highway engineer and working person for 2.5 years now.
यारे मैं 2.5 year के यो मैसेज हमने देखा
हर प्रोग्राम की
और पहला कंपनी वाला बड़ा शान आलसी बिल्डिंग का कॉन्ट्रैक्ट
अस्सलाम वालेकुम फारान हंगुनम और उड़ के वन कंपनी दा एमबीए
Sayyid Rahman Ramada और QS BG के IT इंजीनियर का कोमा और पिशावर था उसका कब पढ़ा QS BG लो सेम स्वेल लांदी
ना अनुषा से بلادي سوقني ده أشياء غدا آخر كبار ما كنت بقول موبايل بندي أو بيجي ما دو خبر إذا مش شكرا ده جا अनुषा से بلادي لما مو موبايل ما ندي سادة شيء بس
सोहेल खटक नोमेदी और एचआर प्रोफेशनल यॉर्कशायर कंस्ट्रक्शन की और डायरेक्ट नजर
बाबर इस्माइल स्ट्रक्चर्स मैनेजर एचपीके कैरेक्टर दवाता
सैफुल्लाह हमने ताल्लुक था यूएस के और 3 मंथ में शूट कतर की जॉब सीखे
بخلونا توصل في الوالد جي ده تصبح دقيقة ساعتين وده ساعتين يعني ده بمرة كان شيركو إذا تاسو دقيقة كذا مشان الله مشيركو شات سا ده فكاري نو هو guidance فكاري نو most welcome was ده تاسو senior ده أو سوي شو
कॉन्ट्रैक्ट सर वो मशरूम
نو نو بوسو لیکو چې څه دغه ده.
السلام علیکم. نوم مې علي خان دی، الیکټریکل انجینیرینګ سواد نه کار.
ځان دی یا سوتیان دی.
زما نوم نجیب دی او دلته ایونسیون کې کار کوم او تعلق مې د سواد سره دی.
زما نوم سلمان دی، تعلق مې تیرا میدان افریدی.
ډېر ښه
electrical engineer as a PNC at Sino Hydro.
زما نوم عبدالصمد دی، زه هم د سواد نه یم.
زه هم الیکټریکل PNC انجینیر یم د CCT.
زما نوم جی محمد اعجاز خان، زه هیډ بلډینګ سروسز ډیزاین انجینیرینګ د قطر ډیزاین کنسورټیم کې او تعلق چې زما مکان سره.
In addition to this, Ijaz by your dear technical knowledge was great. I did nice procedure Rolex key on next presentation in the
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. نوم یې امجد علي توري دی او تعلق پر مې جلسه سره ساتم او لږ څه ویل غواړم.
بالکل.
زمونږ کلي ته یو وخت یو مذهبي سکالر راغلی و، نو هغه نظام باندې خبرې کولې، نو وایي چې یو الهي نظام یې و یو طاغوت نظام. نو د طاغوت یې داسې بیان کړو چې دوی الف غین واو داسې چې دا طاغوت نظام. نو خبرې وکړې 2 غنټې لیکچر ختم شو. نو یو بابا وایي چې زه دې سره ملایږم او د لیکچر باندې زه کمپلیمنټ ورکول غواړم. مولوي صاحب وایي چې نو خو په نورو څیزونو باندې ډېر پوه نه شوم، خو چې د تابوت ایکسپلین کو په دې ډېر زیات ښه پوهېږم. وایي چې هغه خو ظالمه ما خو داسې تا ته دوی الف غین واو ته داسې وویل او تا دې نه تابوت جوړ کړو، نور به څه پرې پوه شوې. نو موږ هم داسې د تابوت او تابوت کې لږ ورته کنفیوز یو. نو د کنسټرکشن سایډ والا دي، ما په خیال چې څوک ټیلیګرام انجینیر پکې نشته چې موږ ته ګایډنس وکړي.
ما ویل چې موږ سټارټ د دې نه غسته دی او دا مخکې پریزنټیشن راځي ډېر فیلډز دي او موږ کول کوو انشاءالله.
دا راشد او رغزي کلیوال دی، ګیله به خامخا کوي.
ګیله خو ته هم ډېرې کوې خو یو ته یو افتخار
بغاوت کوي بغاوت کوي.
السلام علیکم. زما نام سکندر خان دی، زه د HTML کې اسټرکچر یم الو کا بای پاس ورک کې د بلو نه تعلق ساتم.
ما قاسم علي نوم دی، پېښور نه تعلق ساتم او دلته جاب کوم ایز ا سایټ ایڈمن فور هاور کمپیوټر آسکرین کرنی او گریډ 9 میتھ او پروجیکٹ کار کوي. ایز ا سایټ ایڈمن هغې کې کار کوم او کوالیفیکیشن مې MBA بینکینګ اینڈ فائنانس.
دغه مو اگزام درکوم ځکه چې
بسم الله الرحمن الرحیم. دلته راغلم په اول ځل ما راغلم دلته او زما دلته 9 to 10 months شو او زما نوم دی فرمان الله، د پوره خټک نه مې تعلق دی او الیکټریکل انجینیر یم. انفارچونیټلی لږ ټایم مې دلته ویسټ شو دلته کې قطر کې تقریبا 9 to 10 months. کامو کې پیدایش مې دی او سګاین نه سم چاسو یې صحیح نه راغلی دی چې ما ټایم پیدایش زما نو ما یې تاسو کې تاسو دغه چې الیکټریکل جاب لسی یم بالکل اور ډېر زیات تاسو د هغه نیو انتظار متاثره شوم او ان شاء الله کوشش وکوم چې هغه ان شاء الله څنګه وکړم.
السلام علیکم. زه کیسر نوم دی، قطر ایرویز کې پروجیکټ انجینیر یم او پېښور شهر نه تعلق دی.
زما نوم جواد دی، ډاوس کې ریزیډنټ انجینیر یم او صابه یې
السلام علیکم. زما نوم ارشد علي دی، زه ساینو هایډرو سره انوایرنمنټل انجینیر یم او مرغوز صابه سره تعلق دی.
السلام علیکم. زما نور نور کمال دی، وزیرستان میں تعلق دی او ساینو هایډرو سره انوایرنمنټل نیو
ماشاءالله ماشاءالله
अस्सलाम वालेकुम ज़मान ज़ियाद है स्वाबी में ताल्लुक थे ये एनवायरमेंटल इंजीनियर्स एंड आर्ट
माहिर अजमत टल रहे हैं वर्ल्ड पर्सन के ट्रेनिंग इंजीनियर फॉर इलेक्ट्रिकल
अस्सलाम वालेकुम ज़बान नुमान है और फ़िलहाल स्टूडेंट है कॉलेज के हैं और दसवा है
मोहम्मद सुहेल नामा मेरा QDSBG कंस्ट्रक्शंस के सेक्शन मैनेजर है कोहाट ना में ताल्लुक है 16 साल ना कतर के अली सैफुल्ला नईमजान ना जमा यो पेश फेलो दी और कल अगर बढ़ पड़ रहा है
ना पढ़ूं भी जल रहा है
के सुहेल नवानन बट करनी शी
अस्सलाम वालेकुम ज़मान नमस्ते सैफुल्ला ज़ा करकना ताल्लुक में ज़मान और दलता की अशगाल के ड्रेनेज डिज़ाइन इंजीनियर का
अस्सलाम वालेकुम मोहम्मद नईमजान द चारसदे शेरपो और रेजिडेंट इंजीनियर पढ़ा और
अस्सलाम वालेकुम ज़मानुम मेडोरी हम गुना ताल्लुक रहा और बनाना आइलैंड के मेंटेनेंस मैनेजर हैं
ولا ده فكر سنه دي وخيرنا discounts او دغه ريس بروجرام PPIQ بروجرام بنانا عليه اليوم ده اتفاقته
یو خبره کړې وه مې چاته کوي ما که تاسو بنانا آیلینډ ته راځئ او تعلق یې نو پای کې بیا سپیشل ډسکاونټ سي
بس صحیح ده
بس چاته ونه
کم څه تعلق دی
ما چاته نه
السلام علیکم زه عبدالغفار او همګون اریام نه تعلق ساتم او ریسنټلی د الجزیره انجینیرینګ لیبارټریز منیجر
څه لیبارټریز ده टेस्टिंग
एग्रीगेट रोड वर्क एग्जाम्पल को बेटर नहीं हो जो टेक्निकल मसला है साइल वेरिफिकेशन बाकी एग्रीगेट असफार तो बंदे के सबसे भी सबान फिर दी खलीफा हो तकरम सा डिप्ट में लगा रहे अब गलत इंजीनियर है मतलब दैट मा फाइनेंस करेगा ना और बदल तक इंजीनियर मान
गुलामी से एग्जाम क्लास है
अस्सलाम वालेकुम ज़मान रशीद रशीद इज द चासना ताल्लुक लगा अनफॉर्चुनेट इज द टेक्निकल इंजीनियर या यो प्राइवेट कंपनी की एज ए सेल्स कंसल्टेंट का
शाबाश
अफ्रीदाई मामा किराखे पर एजेंसी सर में ताल्लुक है और दिल तार बवकीर यूनिकॉर्न के प्रोजेक्ट मैनेजर हम इलेक्ट्रिकल लवल में पड़े
ये रज़ियो और नफ्स تاسو کې به مړ دا ذکر دی اول خو زه بدرې خبرې کوم دا ډېر ضروری دي نن په دې چت لاندې چې کم پښتانه ناشتي زه ډېر زیات د زړه کې ځار دی چې د زړه مې پسینه کې نه ځایږي پښتون همیشه که پنجاب کې وګورئ که په دنیا کې وګورئ خو یا د ډرایور په نظر کتلی شوی دی او یا د چوکیدار په نظر او یا د فلسفه په نظر باندې نو نن چې زه دا وګورم او د ښکلي افسرانو په خپلو پوزیشنو باندې نو اول خو زه تاسو ټولو باندې فخر کوم او بیا د الله شکر وباسم چې نن پښتون دومره شو چې هغه په دومره ښه پوزیشنو باندې او ښه اسټابلیشمنټ کې کار کوي دا یو د الله شکر د ټولو طرف نه وباسم او دویم چې کوم دی پښتون باندې دا یو ګیله همیشه خلک وایي چې دی په خپلو کې اتفاق نه وي او دی یو بل خبرې راکوي زه بیا په دې باندې فخر کوم چې د درستو دریو کال نه واله تر نن پورې ښه غټ ګیدرینګ دی خو چې د یو بل سپورټ هم نه یې کړی او یو بل مخکې کړی دی او پې فخر هم نه یې کړی نو د رسته کولو او د کراس کولو کوشش یې نه کړی دا هم ډېر دردناک او فاینل زما انټروډکشن بس تاسو له معلوم دی زه خلیفه خان افریدا یم او زه ډېر د غریب سړي بچی یم او داسې زیات تر زموږ چې څومره دلته پښتانه ناست دي دا غریبانان خلک وو الله پاک اوس ورته ورکړلو او زه په دې باندې ډېر زیات خوشاله یم چې نن په هغه ملک کې چې په کوم ملک کې زما پلار دلته کې د اوبو ټینکر چلولی دی په هغه ملک کې زه د 1.5 billion او 1.6 billion senior project manager یم د MOI او دې نه علاوه چې زموږ د MOI ډپارټمنټ کې زه راغلی یم د وروستو 3 کلونو دومره سپیس پکې ما جوړ کړو چې اوس څومره ویریشن ان کلیمز دي د هغې فاینل سیګنیچر زما دی ستاسو د زړونو
خلیفه خبره وکړه چې خصفه خبره چې یاره ما والي صاحب دلته مطلب چې واټر ټینکر چلو او دا یو ډېره غټه خبره ده چې یاره هغه په خپل ژبه باندې ته تعلیم او هغه نن داسې په دې کې نه زه ټولو ته درخواست کوم